All right. Example number 3 says we're going to talk about handling discontinuity of an initial value problem. So when we're asked to find, we can find a particular solution. So there's a lot of terms that we use. So for example number 3, we're asked to find the particular solution of this. Okay. Now, particular means that they usually give you a point because there's no, we're going to find C. Particular means that we're going to find C. And so they do give us a point. They say that this particular solution crosses through the path 0, 3. So what we're going to do is we're going to take the antiderivative. dy dx, if we take the antiderivative as y, so this is the antiderivative 2x is the derivative of x squared, and secant squared is the derivative of tangent x. All right, you guys should know that. And then because it comes from a family of functions, we're going to put plus c. Now, I didn't do this yesterday, but I'm going to do it today. Remember that dy dx represents a family of functions. So I can graph dy dx as a function, and it represents a family of functions. But right now, I want to show you this neat, nifty little trick. If I come into my stats and I change the list, and let's say I do -3, -2, -1, 0, 1, 2, 3. That's a cool thing that it'll let me do, and I'm going to show you why I did that in just a second here. If I wanted to graph the family of functions, normally I have x squared and tan of x and then plus c. Now this plus c is just a vertical translation. In other words, we take the functions and we move them up or down. So what I'm going to do to graph that, to show the family of functions, is I'm going to write x squared, okay, plus, minus tangent of x. And to represent the family of functions, instead of saying plus c, I'm going to put plus L1. Now what that'll do is it'll graph, and let me do a regular zoom on this, we'll do the standard. It'll graph the entire family of functions. And it's going to look a little funny because we have the tangent functions. So that's one, and then what it'll do is we gotta zoom out a little bit. It'll graph. It'll go up one, and so it'll continue to graph the functions. And you'll notice right here, especially along the x-axis, what it's going to do is it's going to continue to graph. It's going to shift up one, shift down one, shift up one, shift down one. Okay? So that's the family of functions. So the plus c, what we're looking for is the plus c that crosses through 0, 3, right? We're looking for the particular solution that crosses through 0, 3. Now, it might not show up here, and then again it might. So this is the first part of L1, which was when c equals -3, and then this is the next line when c equals -2, and so on and so forth. And this very next one should cross through 3. Yeah, here it comes. And so this last one occurs when c equals 3. And that's okay. But now we're going to find that algebraically. Okay? So now to find that algebraically, the only thing I need to remember is that this is the x value and this is the y value. So I'm going to put 3 is equal to 0 squared minus tangent of 0 plus c. Well, now remember tangent of 0, this is 0, right? Tangent of 0, remember that tangent of theta let's make a little side note here. Remember the tangent of theta is really the y over the x. So if we think of our unit circle, tangent of 0 is really going to fall on the point 0, comma 1. So that means that tangent is undefined. This right here is undefined. No, I apologize. I've got that backwards. It's not undefined.
Isn't it equal?
Yeah, it's equal to 0. On the unit circle, this is actually 1, comma 0. Right? So it's 0 over 1. That's what tangent of 0 is. So it's just 0. So this whole thing goes to 0. So we've got 3 is equal to 0. Minus 0 plus c, or c is equal to 3. Which is what I said originally. So my particular solution is y equals x squared minus tangent of x plus 3. So now that's the particular solution. Now the other thing that I wanted to talk about when it comes to vocabulary is that your textbook called this an initial value property or problem. When they use terms like initial value, that's usually a particular solution, which means you should be able to solve for C somehow, some way. Does that make sense? Any questions on that one?